Good morning and welcome to our session, Spray Foam, a Green and Hassle-Free Radon Barrier. I'm Chris Jansen, the Technical Service and Warranty and Applications Manager with BASF. I'm pleased to be here with everyone today. I'll be monitoring the chat room and answering questions as they come in. Joining me is my colleague Ibrahim Hussein, our Codes and Construction Standards Regulation Specialist with BASF, and also Michael Pace, the owner and president of Building Resources, one of our agents for WALLTITE, and we'll be talking to everyone today.
Okay, hello everyone. So I'll start by talking about a bit about the basics of spray foam. What is spray foam exactly? We're not going to go into too much details about the chemistry of it, but just introducing it, and then we'll talk about the changes to the building code and the standards as well, the new regulations that will come into effect early next year. We'll talk a bit about sustainability as well, and then Michael will get into the applications for closed cell medium density spray foam. So we'll see where exactly spray foam can be used in the construction industry. From there, we'll get into radon and soil gas. What is it exactly? Where can it be found? What to do about it? And what does the code tell us to do about it, the minimum requirements? And from there, we'll introduce our solution, which is WALLTITECM01. And then finally, a brief summary of what we covered and the key takeaways. So spray foam has been used in the construction industry for a while now. It can be used in all type of construction projects. We see it widely used in industrial projects, in commercial projects, institutional projects as well, so healthcare facilities, hospitals. We use it a lot in schools, and of course in residential as well. That's a big market, and multi-residential buildings as well. However, polyurethane foam is not only used in the construction industry. We're actually probably all sitting on polyurethane foam right now, on whether it's a couch or a chair. One of the typical uses we see outside construction is in fridges and freezers. Polyurethane is the main insulation product that is used. We also see it in doors and panels. So if we go back to the basics of building science, we know that the building envelope is what separates the outdoors from the indoors, right? So we typically have four extremely important control layers. We have our thermal control layer, that's your insulation. We have the air control layer, that would typically be your air barrier, a water control layer, and then a vapor control layer to control diffusion from one side to the other. So one of the main advantages of closed cell medium density spray foam in general is that it's a versatile product. So that one product can fulfill these four different functions versus having one product that acts as your thermal insulation only, and then a separate product for air, separate product for water, and then a separate product for vapor barrier. So that's one of the really good advantages of spray foam. And then if we take a deeper dive into these different control layers, starting with thermal control layer, we look at the R value of, let's take WALLTITECM01 as an example, which is the BASF closed cell medium density spray foam with the new blowing agent, the HF blowing agent, which I'm going to discuss later on. It has an LTTR value, so LTTR stands for long-term thermal resistance. It's not the initial R value. There's a difference, which again, I'm going to talk about it. It has an LTTR of 5.5 per inch. We compare that to some of the typical insulation products. We see XPS with the old blowing agent, the HFC, at R4.8, and then the mineral fiber at R4. So even when it's used simply as a thermal insulation without looking at its other properties, it still outperforms a lot of other insulation materials. If we look at the air control, the product itself is an air barrier material, but it can also be used as the main component of an air barrier system. At BASF, we do have various air barrier systems for different applications, commercial application as well as residential applications. And they all met the A1 air leakage classification as per CANU-LC S742. So CANU-LC S742 is the standard for air barrier assemblies. That's the standard reference in the building code. And it has different classifications based on the results of the air leakage. So A1 is the best classification with air leakage of less than 0.05 liters per second meter square. So all our air barrier systems were able to achieve that. When it comes to durability and strength, we also know that spray foam in general adds to the overall structural strength of the structure. And our test did show that even when subjected to very high wind gust loads, we're talking here about up to 240 kilometers an hour, the structural integrity of the assembly was not compromised during the test, and all the elements remained intact. It's easily buildable in the field where we did not reinvent the wheel. It's fairly simple, easy. It's not time consuming. It actually saves a lot of time compared to other systems. And then WALLTITE has been, we've had CCMC numbers. It's been since the late 90s. So it's really not a new product that we're just testing right now. That's just an example of a typical air barrier system with spray foam, WALLTITE in particular in this case, being applied on the outside. So notice how there's no detailing whatsoever at the sheathing joints. There's no membrane, there's no tape, there's no sealant, nothing, or at the brick ties. So all we have is a few transition membranes here and there, which are part of the system, but then spray foam and WALLTITE is what's doing the majority of the job here. So you have one layer of spray foam without any joints, without any seams. The building code defines a vapor barrier as a material with less than 60 nanograms, with a water vapor permeance of less than 60 nanograms. Typically for closed cell medium density spray foam, the thickness you would need to achieve that is 2 inches, sometimes 1.5 inches, but usually it's 2 inches. So WALLTITECM01 is a vapor barrier at 2 inches. So if you're looking to use spray foam or WALLTITE as a vapor barrier, then it has to be sprayed at a minimum thickness of 2 inches. When we look at spray foam as a water control layer, we can see how it has a super low water absorption rate, so 0.6% when immersed in water for 4 days straight, and that's with no skins. So the skins of the spray foam is shaved off, but we know in reality on field that's not something we do, so the skin would be there, which means the water absorption would be even lower in reality. And that's what makes it a great drainage plane. It's also flood resistant, and it can be buried. So there's no concern whatsoever if you want to apply it on your foundation, whether it's on foundation walls or under slabs. It can be applied and then backfill directly. Another advantage of this type of application is we eliminate any type of fasteners. So the application process is super easy. It goes smoothly and pretty fast. So we'll get into a bit spray foam again without going into the chemistry. As its name suggests, closed cells are formed which retain the blowing agent, and that's how we get the physical properties of the foam itself. So it's a product that is manufactured on site. You usually have two drums. 50% of the final product is isocyanate, and then the other drum, the other 50% is the actual resin. So the two liquids go through a proportioner unit. They're then mixed in the application gun, and they start reacting together as the liquid is sprayed into the substrate. That's when it starts to expand, and then you get your final product. So later on, when we're going to talk about the changes and the regulations affecting the blowing agent, this is the actual part that we're talking about. It's the blowing agent in the resin that is changing. The rest is not being impacted. A bit of history. So spray foam has been used in construction since the 60s. At BASF, we launched WALLTITE in the 80s. And then due to the Montreal Protocol, CFCs, which were the main blowing agent used back then, were phased out in 1990. And then later on, again, due to the Montreal Protocol, HCFCs, which replaced the CFCs, were phased out in 2010. And now this year, HFCs will be phased out by the end of this year. So the Montreal Protocol, when it came into effect, the main goal was to phase out and eventually eliminate any chemical with high ozone depleting potential. CFCs and HFCs did have ozone depleting potential, but then when they were replaced with HFC, HFC in reality does not have any ozone depleting potential. But the issue with HFC is the high global warming potential it has, which is why there's been an addition to the Montreal Protocol, and that is the Kigali Amendment, which was implemented here in Canada in early 2019. And this amendment targets specifically HFCs. So the goal is to phase out HFCs and then eventually eliminate them. The typical replacement is being the HFO. It has a global warming potential of less than 1. So there's a hard date to keep in mind here, January 1st, 2021. No foam plastic can be produced in Canada with HFC blowing agent. So all production will have to stop by that date. The typical replacement, again, it's the HFO blowing agent. Here at BASF, we have WALLTITE CM01, which is our spray foam with HFO. It's been available since 2017. So it's a product that we tested. It's a product that we tried. It's not something we just started developing as we approach the deadline. So we really are comfortable going forward with this type of product that's been available for a while now. So one of the main questions we get asked when it comes to the differences between HFC and HFO is, how are the physical properties impacted? And in reality, there isn't that much changing. If we take WALLTITE CM01 and compare it to the previous generation of spray foam, the density is in the same range. So for WALLTITE CM01, we have a density of 1.85 pound per cubic foot. It used to range between 1.8 and 2.5. The R value, however, is slightly lower with the HFO foam, and there's two main reasons for that. The first one being just switching a blowing agent. It's the difference between the two blowing agents is causing that slight reduction. But the second reason there's a reduction in R value is that the test method that we use in the standard to determine the LTTR, the long-term thermal resistance, has been updated in the newer version of the code. So the method is different than what was done in the previous version, which is causing that slight reduction. So even if you took two HFC samples, the exact same product, and tested to the old version of the standard and the new version of the standard, you would have different results. But the big change here is really the global warming potential. Looking at the blowing agent itself, we went from a global warming potential of over 1,000 to less than 1, and that's a significant improvement. If we look at the finished product, let's take a surface area of 1 meter square, thick enough to give you an RSI of 1, so that's an R value of 5.68. We went down from 20 to 4. So again, it's really a great improvement. In terms of other properties, nothing much has changed. It's still an air barrier material. When sprayed to a certain thickness, it will act as your vapor barrier. Water absorption is really low. You can use it as your insulation from the inside, from the interior, whether it's between the studs, directly on your foundation wall, It can also be used on the exterior as your continuous insulation either way, and it still contributes to the overall strength of the assembly. So by now, I'm assuming that the majority of designers and are familiar with an environmental product declaration, or an EPD. And what an EPD is, it's basically a document that tells you and gives you the whole story of the environmental impacts of the product. We're talking about the full life cycle assessment of the product. So from the extraction of raw materials to the installation on site, to its use throughout its service life, all the way to the disposal. And then every stage of its service life also includes transportation. So if there's transportation at any stage, it's also included in the overall environmental impact of the product. So that's a document that can be very useful, especially if you want to start comparing different materials, different insulation materials. And the functional unit allows us to do that. So any insulation material with an EPD would have a functional unit of 1 meter square in area and thick enough to give the same R value, which is an RSI of 1, or R 5.68. This is not a document that manufacturers would prepare themselves or create themselves. So it cannot be just any document that we would create and it says whatever the manufacturer wishes it to say. It's actually independently verified and based on ISO standard. So as a spray foam industry, we do have our EPD with ASTM. If you just Google EPD-085, it should be the first result that pops up. If we take the global warming potential of different insulation products from the respective EPDs and throw it on this chart, you can see how WALLTITECM01, which is the new generation of spray foam at BASF, does comparing to other materials. Just comparing it with WALLTITE V3, which was based on HFC, you see that significant improvement from a GWP of 20 all the way to a GWP of 4. If you compare it with XPS, it's still very much lower. But the interesting thing here is WALLTITECM01 is now actually lower than high density mineral wool, which is typically used on in exterior applications, and very close to mineral wool bat, and not that far off glass bat insulation. But there's one point to keep in mind here when you start comparing different material. We did mention earlier that spray foam and WALLTITECM01 are so WALLTITECM01 is a versatile product. It will fulfill more than one function, and that's not really reflected in the EPDs. So if you really want to have an accurate, if you really want to accurately compare different products, it's also a good idea to look at the actual assembly. So you take your entire assembly, whether it's a wall assembly or something else, and then take into consideration all the different materials or control layers that are used, and then from there you're going to have a more accurate GWP for your assembly. So let's say for example, if you take your typical fibrous insulation, you're going to need a separate vapor barrier, typically your 6 mil poly. You might have a separate air barrier from the outside, whereas with WALLTITECM01, it's taking care of all of that with just one material. A great thing about the EPDs is if you're looking to have your project LEED certified, then you get points for choosing a material that has an EPD. Again, just Google EPD-085, you're going to get the EPD for spray foam with HFO. We also have an HPD document, which is Health Product Declaration. It's basically a document that ensures accurate and reliable reporting of ingredients used in the product. So choosing a product that has an HPD will also allow you to get points and credits. Spray foam is manufactured on site, so you can get points under regional materials category, and and you can also get points under the low emitting materials. So our product WALLTITECM01 is compliant with the California Department of Public Health standard method, which means there's low VOC emissions. We also have our Green Guard certificate. We also have the Green Guard Gold certificate, so stricter limits, and that's to take into account and into consideration sensitivity of certain groups of people. So typically schools and healthcare facilities would require that type of certification. And finally, we also have our eco logo, which certifies that the product has a reduced environmental impact. So there's many ways to get points for LEED using WALLTITECM01. Moving on to the codes, as you might all know by now, the National Building Code gets updated every 5 years. So the current version is the 2015 National Building Code, and it replaced the 2010 National Building Code. Now, typically, you would have a lot of changes and technical changes to articles and provisions in the code, but that's not the only change you would have from one version of the code to the other. A lot of standards are either updated or removed, or new standards would be added. So if we take a look at the standard for the material spray foam, closed cell medium density spray foam, KNU-LCS 705.1 is the material standard. So the version that was referenced in the 2010 National Building Code is the 2001 version. That's why we have -01 after S705.1. And then the 2015 National Building Code now references the 2015 version of that standard. That's where the -15 stands for. So if we compare the two standards in the two different codes, we know that the 2015 is now being used in most provinces here in Canada. Ontario as well harmonized their code, their OBC, with the 2015 National Building Code. And one of the standards referenced in this S705.1 is the LTTR test method, so S770. In the 2010 Building Code, the method that was referenced is the 2003, and now the 2015 references the 2009. So it is a more complex method. The way we prepare the samples is different. The way we do the actual calculation to determine the LTTR is also different, and that is why you would have slightly lower values when following the 2009 standard. Another change is that in the previous version, the initial thermal resistance had to be included, whereas in the 2015, it's not to be included anymore. And that's not a bad thing, actually. We did see a lot of confusion, people confusing between the initial R value and the LTTR. And it's really important to keep in mind that the only R value that can be used for the design is the LTTR, whether you're following the 2010 National Building Code or the 2015, it's always the LTTR value that matters. So at this point, having an initial thermal resistance does not mean much. So by having it removed will actually clear a lot of confusion, but we still see it out there. So just be careful when you're dealing with R values. Another big change between the two different versions is that we now have a limit on how much the spray foam sample can shrink. So new dimensional stability requirements, and fungi resistance is a requirement now. So no fungi growth whatsoever on the sample is allowed. And I'll turn it over to Michael from here.
Thank you very much, Ibrahim. So really, WALLTITECM01, which we've mentioned so far in the presentation a few times, is really a game changer. It has the has the HFO blowing agent. It's compliant with the 2015 version of the standard, which is required by the code, as Ibrahim mentioned. So in turn, it also has the 770-09 R values on the data sheet. So those are listed. And you can use it in all the same applications that you could use WALLTITE V3 in. So whether it be below grade, above grade, cavity wall, whatever it is, the applications do not change. And most of the properties have remained unchanged, with the exception of the R value being a little bit lower. So it's good to be aware of that, just slightly lower. We still support the product with all the same infrastructure at BASF. So it has low GWP, low global warming potential, even relative to things like mineral fiber insulation. So that is really a big game changer for us. The R value is higher than most materials that are on the market. It's multifunctional, as Abraham mentioned. It's an air barrier, vapor barrier, and it will perform other functions within the building envelope and prevents growth of mold and fungi. The versatility, and you can see here in the picture here, all the different places you can use WALLTITE. And we've done projects like this where we've used it below grade, on the outside of the foundation, under slab, cavity wall, and between studs. We'll talk a bit more about that. So cavity wall is what we're often thought of in commercial construction. There's probably thousands of schools in Canada done this way. Concrete block or CMU with WALLTITE applied over it, and then masonry veneer. Very common application. And there you can see how it conforms and works around the brick ties. You can see some transition membrane in the lower part of the picture on the right-hand side. The blue material, the transition membrane. But it's quite a fast and simple approach to creating a good building envelope in commercial projects where you're using it as continuous insulation. So there's a shot of, that's Woodstock Hospital, actually. In some cases, oh, pardon me, the slides went a little fast here. In some cases, it's more space efficient to use the WALLTITE on the outside of the sheathing, but also to use some of it in the stud space, in the stud cavity, just to make the wall more compact. So that is another option. And we see that in retail environments. And here we see it on the inside of precast exterior wall panels. And on the right-hand side, you see a picture of a project which is in the west end of Toronto, which is completed now. It was completed earlier this year. There's 2 towers, but that's a pretty common application in the last 10 or 15 years, where we're using WALLTITE on the inside of precast concrete wall panels. We can also use it on the inside of spandrel panels and also solid masonry in older existing buildings. You can apply it overhead without the need for fasteners. So whether it be overhead in residential, like on the right-hand image, you can see the joists and such, where we're applying the WALLTITE between the joists, or where there's no support. It's just relying on the adhesion to the concrete surface or the wood surface, as shown in the graphic on the left. So we don't need any fasteners to keep that WALLTITE in place. And you can use it in attics as well, as an attic insulation on the floor of the attic, if you will. And you can supplement it with other insulations like fiber, mineral fiber, or cellulose to reduce the overall cost and get the sort of good cost-benefit ratio from the WALLTITE. We see it also in cathedral ceilings in residential construction, where you're insulating without a vented space. So we eliminate the vented space in cathedral ceilings. This is something we've been doing for about 30 years, very successfully. And you can also use it in residential wood frame wall construction as part of our BASF HP Plus high performance wall system. And in this system, we're using it in conjunction with Neopor GPS, which is the graphite enhanced polystyrene, which also has a very low GWP of about 3 versus the WALLTITE, which is about 4. So it's actually lower than the WALLTITE, so very low. And we also have been using WALLTITE below grade for many years. This is an exterior foundation wall. In this particular project, on the right-hand side, you see the picture. There's no waterproof membrane required because of the water table not being very high in that location. But in some cases, you do need a waterproof membrane, which we would apply first and then apply the WALLTITE over that waterproof membrane. And the beauty of it is the WALLTITE does not require any fasteners to remain in place over that membrane, whereas you would require fasteners if you're using board stock insulation or other insulations. And here we have it on the inside of a foundation wall and also under the floor slab. And that's really what we're going to be talking about more in a moment. So here you see it under the floor slab, and it's very robust. It conforms to the subgrade. So if the subgrade is a little bit uneven, it's not packed perfectly smooth and flat, which is typically the case. The wall type will conform to that uneven substrate and provide a good working slab for the people applying installing the concrete and or hydronic systems. And to give you an idea of the durability of wall-tite versus extruded polystyrene, which is very commonly used under slabs as insulation, the wall-tite CM01 actually has a higher compressive strength when you compare it to extruded polystyrene. So it's 34.2 psi versus about 30 psi for typical type 4 XPS. So it's plenty strong for the kind of impact and mechanical damage that might occur when they're pouring concrete over it, walking over it, and that kind of thing. At this point, I'm going to turn it back over to Ibrahim to talk about the soil gas and radon control features.
Yeah, thank you, Michael. So let's start by defining radon. So radon is a radioactive gas that occurs naturally when the uranium in the soil and rock breaks down. The issue with this type of gas is that it's invisible, it has no taste or odor. So it's really impossible to detect without having a specialized device like a radon detector. And that's why we should really take it seriously. Now, certain areas are known for higher amounts of radon due to the high amount of uranium in the soil, but the truth is that radon can be found anywhere in Canada. It can actually vary even from house to house. You would have two houses on the same street. One house would have high levels of radon and the other one having nothing detectable. So it's really important to have that radon barrier whenever we're dealing with new constructions. It's in fact the second leading cause of lung cancer, which is why it's really important to address the issue. And we know that in the NBC and the OBC as well, there are provisions to deal with radon, which we're going to look into in a few moments. So how can it get into our enclosed space? So if we take an example, a typical example of a basement, or even if we start with a crawl space, if your crawl space, as you can see here, is exposed, there is no concrete floor or anything, it's just exposed soil and rock, that's a really easy entrance for the radon into the house. If you have cracks in your foundation walls, which we know is very common in construction, that's also an easy entry point. If you have cracks in your floor slab, you can have radon penetrate through these cracks, no matter how tiny they are. The intersection of your basement wall and your floor slab can also be a weak point, which will allow radon and soil gases to come inside the house. Any holes in objects such as support posts, around utility penetrations, around support posts, all of those are entry points. If we take a CMU wall, a concrete masonry unit wall, same, it's really the same concept. Again, the intersection between the blocks and your floor slab, that's an entry point. Any cracks in the blocks, any missing mortar or cracked mortar, that's also an entry point. Unclosed voids at the top of the exterior wall can also lead to radon penetrating into the house, as well as the pores themselves of the blocks. Now, when it comes to existing construction, there isn't much that can be done. Usually, one of the best ways to deal with radon is sealing any crack. So any visible cracks, go ahead and seal it. But then another alternative or something else that can be done in addition to sealing all cracks is adding a subslab depressurization system, which isn't that easy when it comes to existing construction, but it's still doable. So one of the truth is that one of the most effective ways to reduce levels of radon is through a depressurization system, which is what we see here in the picture. So it does involve installing a pipe throughout the foundation floor slab and attaching a fan that runs continuously to draw the radon gas from below the home and release it to the outdoors. Once it's released to the outdoors, it's going to dilute and it's not going to be a health concern at that point. This image here shows you two different options. Usually you see the exhaust pipe go through the rim joist at the floor at ground level, and in some cases where the fan would be placed in the attic space, then the exhaust would be at the roof level. Now, the National Building Code or the Ontario Building Code, they do not really require you to have that system in place. However, the rough fin of the system should be installed in new construction. So in case levels of radon will be detected and they're going to be high, there is an easy fix since the rough fin is already installed in place. So you typically have your rough fin and then your concrete slab would be poured right after that. Now, although that's one of the greatest way to get rid of high levels of radon, it's not the only measure we have to take. We know that we have to create a great barrier against radon and not just depend on the depressurization system itself, which is what's required in the building code. If we take in the National Building Code, and if we take the Ontario Building Code as an example here, it says that all wall, roof, and floor assemblies in contact with the ground shall be constructed to resist the leakage of soil gas from the ground into the building. So we're not just talking about slabs here, we're also talking about the foundation wall itself. So it's not enough just to insulate or create that radon barrier under the slab, but you should also have that radon barrier on the wall, on the basement wall. So we see typically what's required by the code, the very minimum is the 6 mil poly. That's what we typically see in construction. But it does require a lot of work. There's a lot of sealants around penetrations. There's a lot of taping involved. You want to make sure all the cracks, the perimeter is perfectly airtight. So basically you're dealing with the whole system as if it's an air barrier system. There isn't a big difference between a radon system and an air barrier system. It has to be continuous and it has to be perfectly airtight. The images here show you a typical example as required in the OBC. So you do not only have your soil gas barrier under the slab, but at that intersection between the slab and the wall, as we said, it's an entry point, so it has to be sealed with a flexible sealant. And from there, I'll turn it over to Mike, and then he's going to introduce our system.
Great. Thank you, Abraham. So, yes, it's possible to build according to the SB9, to those sketches that Abraham showed in the previous slide, using 6 mil poly, taping the laps of the 6 mil poly, and sealing it around all the penetrations. Remember, you have to pour your concrete on top of that, and then you have to caulk all the cracks in the concrete and caulk between the concrete and all the penetrations. So you end up with a lot of caulking. I've heard estimates in a typical basement of $2,000 or $3,000 in order to do that sort of system by the time all the caulking is done and the polyethylene is placed and taped. In commercial work, we see people going with a thicker polyethylene membrane, like shown in the picture on the left, the green material. It's a 10 mil poly, and there's reinforced polys. But no matter what polyethylene or what membrane you're using, you have to detail it at all the penetrations, and there's still no guarantee that it's going to really be airtight because most of them are not bona fide certified systems for controlling radon. So they have their weak points for sure. With WALLTITE, we're applying the WALLTITE. It naturally seals around the penetrations. You can bring it up the wall, either just the thickness of the floor slab to create a thermal break, or you can bring it right up the wall and basically tank the basement. So we're showing that here in the picture. And there's the way the picture here shows how it seals around all those penetrations for plumbing and various things that are coming through the floor. We also have a short video that we can show you. There we go. So this is in real time, and you can see the applicator is applying it right to the prepared granular. The granular is prepared exactly the same way as you would if you were using polyethylene membrane and extruded polystyrene. So there's no difference in the way the subgrade is prepared. And you can see they're applying it right to it and around the penetrations, checking the thickness as they go. And you'll notice there's a light coat of the WALLTITE on the floor first, and then the heavier coat to build up the thickness. So WALLTITE, in order to talk about this product really as a system, we had to go to CCMC and test it according to the technical guide that they created to prove that it is a radon control system, a radon barrier. And you can see here in the picture basically how it works, dealing with all those cracks in the concrete. The radon doesn't get that far. It gets to the WALLTITE, and then ideally it's either dissipating through the granular subgrade or it's vented using one of those depressurization systems. That's a mouthful. So this is the cover of the CCMC report 14152 that refers to WALLTITE CM01 as a radon control barrier. And the box there basically saying WALLTITE CM01 when installed at 50 millimeters shows better resistance to radon than 6 mil polyethylene, which is the National Building Code benchmark. And this is a detail that's from that same report where you can see the WALLTITE being applied under the floor slab and then up the wall and creating that sort of tanking effect that we discussed. And typically we're applying the WALLTITE at the 50 millimeters or whatever is required to meet the part of the code that you're trying to comply with. And as I said, it's robust. So when the contractors are walking on it, as they're installing hydronic systems or placing concrete on it, the typical construction traffic, it can definitely withstand that. And the nice thing about it is it doesn't move around underfoot. There's no voids under the WALLTITE because it does conform. Whereas with board insulation, you typically have some rocking and possible cracking because of the unevenness of the subgrade. So this shows a WALLTITE, a typical application. You can see the smoothness of it. You can get it flat enough to apply concrete over it. And so really there's a lot of advantages when you're using WALLTITE under slabs on ground compared to other systems. It is compliant. It is a system and considered a radon, part of a radon control system, a radon barrier as per the CCMC listing and report. It's durable, so it conforms to the subgrade. You won't get rocking and moving around of the WALLTITE when they're placing the concrete over top of it. It is very simple, so it functions as the insulation, radon barrier, and vapor barrier, and in fact an air barrier as well, but that is part and parcel of it being a radon barrier. And it's cost effective. So it ends up being very cost effective compared to 6 mil poly and extruded polystyrene. Typically it's a cost saver, but it can be very, very competitive with those systems. So in closing, just to reiterate a few things here, BASF is a large manufacturer. The WALLTITE CM01 has a track record. It was developed in 2017 and been on the market, many successful installations. We have a large network of field technical staff and certified applicators right across Canada. And they're there to install this product according to our technical guides. It's compliant with current and future building codes. As you can see, we've tested it to all the latest standards. We actually have people in the company that participate in code committees and standards committees, so we see these things coming, and we prepare for that. And the spray foam, and this is really the game changer part of it, it's always been respected as a good insulation, a good vapor barrier and such, but now it's that much more sustainable. So it's more sustainable than many other insulations on the market. It has low GWP, even compared to mineral fiber, and definitely compared to extruded polystyrene and other plastic insulations. And as I said, it's code compliant as a soil gas barrier as per the CCMC report. Some of the things that, some takeaways, if you will, is your specifications do need to be updated to include some of these references. So the third-party quality assurance program provider, in our case, we use Caliber. They work towards a standard called CAN ULC S718. So that should be included in specifications. The specs should also refer to HFO blowing agent spray foam only. And of course, the latest version of the standard, as per the OBC regulations, the CAN ULC 705.1-15, that -15 is very important. And the LTTR values that are used for design and for heat loss calculations and such, modeling, need to be as per the S770-09, the 09 version. So these things should all be reflected in your specifications. Some ways we can help you with that is we provide guide specs, short form and long form guide specifications that capture all of these new changes that are happening out in the industry. We also we're available to update your current specification section. So if you have a spec section for spray foam already, which you likely have, we can update that for you to incorporate these standards into the format that you're already familiar with. We can also help you with effective R value calculations to help address the slightly lower R value of the CM01, or to put that in context based on an analysis of your wall assembly and the effective R value of that wall assembly versus the target effective R value that you need to attain. And of course, we can offer site inspections using the BASF technical staff, and we can also organize third-party site inspections for you as well to ensure that you're getting everything's being installed as per the standards. Thank you, everybody, for participating in this presentation, and I hope you found it informative. At this point, I'm going to turn it over to Chris, who's managing the chat box, to talk about to field some questions that you may have on spray foam insulation.
Yeah, thank you, Michael. Thank you, Ibrahim. A very informative presentation. Glad we could sit in through this. One of the questions we commonly get that's with regards to these types of presentations are, what are the costs of using spray foam versus alternative methods for insulation?
Well, typically in a cavity wall application, because we're eliminating the need for full coverage air vapor barrier membrane, we're saving quite a bit of time and money there. So we're quite competitive, even compared to using, say, mineral fiber insulation and a full coverage membrane. Switching that to transition membrane and wall-tight CM01, we're going to be a cost saver typically, but also a schedule saver, because it's installed much more rapidly, much faster than the alternative.
You know, one of the other questions that we commonly get is, how do people learn more about incorporating spray foam into their projects? Ibrahim, can you provide any guidance on that?
Yeah, sure. So as a company, we do provide a lot of technical service. We do typically a lot of lunch and learns. So any architect, designer, or anyone who would like to learn more, we can always provide lunch and learning sessions. You can always visit our website and send us an email directly. And you can visit our virtual booth today and book a meeting with us.
Great. Thanks, everyone. everyone for your time, and we look forward to chatting with you at our booth.